Now we are going to implement the multinomial naive Bayes classifier, and for that we have a dataset which is named as fetch20 newsgroup dataset. Here you can see in the sklearn library also, it comprises around 18,000 newsgroup posts on 20 topics split into two subsets, one for training and other is for testing. So you can see it from the documentation over here, and that I have only done that from a sklearn dataset import fetch20 news group, and I've stored that in the news variable fetch20 news group. Or if you want to download the whole dataset and then from the test and the train classes, then you can click from here and download that particular file. Next I want to print the keys, that what are the keys which are present there in this dataset. So these are the keys which are there. Next I'm going to print the target values, that what are the target values. So target values are actually, there are 20 target value which are there, and these are the target names which are there. Ethism, graphics, Windows X, Forescale, autos, motorcycle, these are the target names. Now we not want to operate on all the target names, so I'm selecting only 4 categories on which we are going to perform several operations. So these are the things which I am selecting here from these categories, that is ethism, religion.christian, graphics, and science.men. So that I have stored in categories, and that I'm using as new string. So that is here. Next, in news test we use for the rest, I'm using for the test category in the test feature, and the subset I have named as test, and the categories are same for this. So next, if I want to print the keys and also print the news strain target name, so I have to write like this. And so now here you can see that these are the keys and these are the target names which are there. Next, what I'm going to do, now there are also in the text, so I'm going to use the count vectorizer function so that the system or the computer can itself assign the number to the text which are there in this particular field, because we know that we can do it with our mind and sense, but how will a machine recognize several texts? So what it does, it gives a unique number to the value. So for that we have to firstly import from the sklearn.feature extraction.text count vectorizer, and then we have to implement on the trained dataset and then check the shape of it. So let us do that. So here you can see that I have used the sklearn.feature extraction text import count vectorizer, and in count vect variable I have stored it. And next, what I'm going to do for the trained dataset, I'm going to fit and the transform function we use for train.data, and then print that. So here you can see that I have written it, and next what I have to do, I have to print this TF, and also I want to print the shape of it. So I have to write like this, print xtrain TF, and also print the shape of it. So here you can see that I have written the complete code, and as I execute this particular cell, here you can see the numbers have been given which have been assigned, and all the numbers have been given. And lastly, we're going to check the shape also, that what is the shape. So here you can see that 2257 representing here the number of rows, or we can say the number of samples which are there, and 35788 represent the number of columns, or we can say the unique word and feature, and the classes are respectively 0, 1, 2, 3 are the classes which are there. Next, what we're going to do, we're going to use the TF-ID transformer, and I've explained you also what it does. It actually weights the word of the classifier. If any words get repeated multiple times in any text, then it finds out how much is the contribution to the model in the classification. So let us write for that also. So here you can see that I have written from sklearn feature extraction text import TF-ID transformer, and that I have applied using a variable TF-ID transformer. In train TF-ID, we have fitted the value of xtrain TF and then print the shape of it. So here you can see that it represents the same values. That means there is no repetition of the words, shows that there is no change in the number of words. Next, we need to train the model, but here we are going to use the multinomial NB in place of Gaussian. So we will simply write from sklearn.naive import multinomial NB, and then we will train and fit our model of this TF-ID value and new strain.target value. With the multinomial NB classifier, we train our model, and while training the model, we take two parameters. First is the transform data, and the second are the category of classes which we classify our text. So here you can see that I have imported the multinomial NB, and also in the CLF variable, I have stored it, and using fit function, I have trained the model with the two data sets which are there, xtrain TF-ID and the matrix target which is there, by which we classify the text. After that, what we need to do, we need to test our model. Now before testing, we have to also transform our data like a trained data set. If we do not do this, then our model will not recognize this data and the chances of error will increase. So firstly, we will transform our test data like trained data. So here you can see that I have used the transform function for doing that. And next what we do, we use a predicted variable. And in this variable, we always use for prediction. So clf.predict. And we predict the X test. And here we have TF-ID. And lastly, we print this variable. So here you can see that an array of prediction has been generated. So this is our array which has been generated. It classifies our test data into classes we have, and you can also use any other text other than the text data or the test data. Now we can use to check the accuracy of our model, that what is the accuracy, and for that we import from the sklearn.matrices and we import the accuracy score for it, and for printing the confusion matrix similarly we take it from the sklearn. So here you can see that I have written the code for it, and this is very simple, which we do for all the modelers lastly after training and testing and predicted value. So you can see here that this is the accuracy 83%, which is quite good, and all the diagonal values represent that these are the correct prediction of the confusion matrix and rest represent the incorrect prediction. So this is the complete set of code for the real world dataset which we used our 20 news group, and this whole code is also mentioned and written in a form of tutorial in our official website, and the link will be given to you in the video description. This is all about Naive Bayesian classifier using multinomial classifier.